where I got to something and I was like, oh, well, that's not right. And so I just, instead of kind of redoing the video or wasted time, I just kind of cut it off to fix the problem. The problem was simple. It was a really obvious thing. You might have even noticed it. It was just what I typed right here in this moment that was the boo-boo. But it's kind of hard to figure out what you're doing incorrectly, kind of in the moment like that. So that's why I had to end the moment. So where we last left off, we had worked out our slope. And our slope, if you recall, was negative 0.056. We were going to plug in x and y to find the value of b. We were going to use as our y value 0.7829. And we were going to use as our x value 30. And we were going to solve for b, and that's when I went to the calculator. The mistake I made was in multiplying these two together, that's correct, that's this value. But what I did is, I guess I was trying to save time and rush, because the video was running long. What I was supposed to do was add 1.68 to this value. And what I ended up doing was add this value to this value. Just went the wrong way in solving the equation. So let's do it correctly and take 0.7829. Oop, gotta turn it on. Let's take 0.7829, add 1.68, and that should be our correct y-intercept. I knew our y-intercept was wrong because it was negative and there was just no way you could have a decreasing function above the x-axis that somehow had a negative y-intercept. That was just illogical. So let's write out our linear equation. Negative 0.056 x plus this value, and I know it's running out of room here, but we're going to add it to right there. The last thing we have to do is use this to predict when we will hit 0.5 as a total. So what that means is we're going to plug in 0.5 for our y value and find our x value, or in this case, I guess solve for the time. So in goes 0.5 into our linear equation, which I guess I got to write super small, plus 2.463. Sorry about that, but all we're going to do is kind of solve this for x. So over here in the calculator, we're going to do that work, and we're going to hopefully do that work correctly. We're going to take 0.5. First, we're going to subtract the y-intercept, and we can even use the answer feature in our calculator to do that. Then we're going to divide by this value, and that should solve for our x. So we're going to divide by negative point. And I believe it's 0.056. I know some of you are looking right here and saying, Mr. Malsby, you wrote it wrong. That's true. Mr. Malsby is slipping. But this is what we get, 35 days, right? That seems reasonable. We got the 0 to 30. 35 is kind of an estimate for when we're going to hit half a pound feels right. If you got something like 0.35, that would be a bad sign. So first thing let's do is let's write the corrected linear equation where I include the right amount of zeros for the slope. And then let's write our solution when we set it equal to 0.5, which is, really I guess we should say the answer is the time, t equals 35 point, what appears to be 052 days. All right, hey, sorry about the little kerfuffle, and thank you if you actually were patient and just kind of watched the correction video for part D. I know it was about 25 minutes total, but I hope you learned something, especially things like average rate of change. There's a formula for that. You're going to use it 4 or 5 times on the exam. Make sure you know that f of b minus f of a over b minus a. Also, average value formula. You're going to use that 2 or 3 times on the exam. It's similar to the average rate of change formula, but it involves the integral, 1 over b minus a times the integral. And also make sure you know how to do a tangent line, and also make sure you know how to explain the meaning of slope and use the features in your calculator. Those are all skills that you're definitely going to get tested on. All right, thanks again.